It was the hole was like this, and then I caught on, and I just went and kept walking. Oh. But I have a safety pin I'm gonna put on it. Or I should just stay with it. Yeah. For right now. Yeah. You have a safety pin. Oh. I'm about to have a whole go.
Alright. This is really simple. Imagine if you said to me, what if there was a molecule, but it had a charge? Because molecules usually have zero charge. Well, if it had a charge, we wouldn't call it a molecule, we'd call it a polyatomic ion. That's it. So it is they are molecules with a charge.
That's it? I'm in bed.
This means you have a couple atoms stuck together with covalent bonds, but then they have a charge. So let's look at a couple of them. I'll just draw a few for you. One example looks like this. You have a phosphorus with oxygens attached to it. And when you look at this, you're thinking to yourself, I know what you're thinking. You're thinking, look at those oxygens at the top and the right and the bottom. They should have two bonds, right? Oxygen always makes two bonds. So since it's missing one bond, it just picks up an extra electron and ends up with a negative charge. And that happens to all three of these oxygens. They all have -1 charges. Okay. This one's okay, has two bonds already, it's happy. But the other ones have to pick up random electrons because all the oxygens need to make two bonds. They would need 2 more electrons. Okay, so that's a polyatomic ion. It looks like a molecule, it's got some covalent bonds, but it has a charge. What's the formula for this?
PO4.
PO4, and then what's the charge going to be?
-1.
-3.
Oh,
Because there's one on each of them, so the total
oh,
is
so
-3.
it's 3.
Okay, so we don't name polyatomic ions like regular stuff. We're not going to call this phosphorus tetraoxide or something like that. They have special names for most of the polyatomic ions. This particular one is called phosphate. And if you see this ATE or if you see ITE, it usually indicates something with oxygen in it. Let's do another one. Let's do sulfur with some oxygens attached. And again, same thing. The oxygens that only have single bonds end up with negative charges. And what's the formula going to be for this one? -2. Right? Yep, that's it. So that's what polyatomic ions are, basically. They're just molecules that have charges. And for today, all I really want you to be able to do is if I give you the formula, I want you to be able to tell me the name. Now, how are you going to do that? It's really simple. Take out a textbook and open page 257. And by the way, if you're at home, you could simply Google the formula, right? I mean, you know, this is the table, but you can do that.
It's 257.
257. By the way, this is going to be your new list that you're going to start memorizing, so get used to it and get comfortable with it. I want you to know these. 257. So let's say I give you one of these, and I want you to tell me what the name is. So let's do CN. All right, so what's that called?
Cyanide.
Cyanide, that was pretty quick. Cyanide. And what's the charge?
2. -2.
Yeah, it's -1.
Alright.
Where are you getting that from?
Because I thought it was, because see, my binder is covering the top, so I thought it was charged 2.
All right, I forgive you. All right, let's do one more. No, not that one. What's this
I
one?
can't see it.
ClO3. That's a lowercase l. What is it?
Chlorate.
Perchlorate. Yeah, this is perchlorate. Yeah, chlorate would be ClO3. And what's the charge of this one? -1. And you'll notice most of these ones are on the list are negative. Right? Most polyatomic ions we deal with are negative. All right, so this is all you got to do on your worksheet. Give me the name, give me the charge. That's it. Good?
Alright.
That's it?
Yeah. Tomorrow I'll give you compounds. We'll name the compounds that have these in them. Next day we'll find the formulas, but for now we're just doing this.
They say the what movement line is. I get you something.
Not likely.
You don't like them?